When talking about computers and programming, you may often come across the terms interpreter and compiler. While both translate your code into something a computer can understand, they work slightly differently. Today, we'll break down how each one operates, explore their pros and cons, and see how they impact the performance and functionality of your code. This video will clarify the roles of interpreters and compilers in software development. So let's dive in. Let's first clarify what an interpreter is. An interpreter is a program that translates high-level language code such as Python, Ruby, or JavaScript into machine code. Machine code represents instructions in binary form that are directly executed by the computer's CPU. If you're interested in delving deeper into binary representations like bits and bytes, check out our videos on the topic in the video description below. The interpreter processes the code by executing each line individually, allowing for flexible debugging. However, this real-time translation during execution means interpreted languages are generally slower than compiled ones. Despite this, interpreters still play a vital role in development, enabling rapid testing and iteration, and their adaptability makes them indispensable in dynamic programming environments. Now let's analyze how a compiler operates. A compiler is a program that translates code written in high-level languages such as C++, Java, or Rust into machine code. Unlike an interpreter, which translates and executes code line by line, a compiler processes the entire source code in one go, translating it into machine code and producing a standalone executable file. Some programming languages, such as Java or C#, also create intermediate files, bytecode or intermediate language, that are later executed by their respective runtime environments, JVM or CLR. This ahead-of-time translation typically makes compiled languages faster than interpreted ones, as the code is fully converted into machine instructions before execution begins. Compilers optimize the code for performance and resource efficiency, producing highly optimized machine code that runs quickly and uses resources effectively. This makes them essential for applications where speed and efficiency are critical, such as system software, real-time processing, and high-performance computing. Additionally, because the translation is completed before execution, compiled programs often benefit from enhanced security and stability. Now that we know about both interpreters and compilers, let's compare them and analyze their respective pros and cons. Neither is perfect, and the choice between them depends on your project's specific needs and demands. Interpreters offer the advantage of executing code line by line, which makes them excellent for rapid development and ease of debugging. This allows developers to quickly identify and fix errors, making interpreters ideal for scripting languages and educational purposes. However, this real-time translation can lead to slower execution speeds compared to compiled languages. On the other hand, compilers translate the entire source code into machine code before execution, resulting in faster runtime performance and more efficient use of system resources. Compiled programs benefit from thorough optimization, which enhances their speed and stability. Additionally, compiled code is generally more secure, as it is harder to reverse engineer and tamper with. The downside is that the compilation process can be time-consuming, and debugging compiled code can be more challenging, as errors are only identified after the entire codebase is compiled. Ultimately, the choice between an interpreter and a compiler depends on various factors such as the development timeline, performance requirements, and the specific goals of your project. For quick iterations and dynamic environments, interpreters might be the better choice. For performance-critical applications where execution speed and efficiency are paramount, compilers are typically more suitable. Understanding these trade-offs will help you select the right tool for your programming tasks. That wraps up our exploration of interpreters and compilers. If you enjoyed, consider subscribing to our channel and liking the video. Thank you for watching.